Aim. Zeros of a function. Please take a moment and copy down the notes. I'll go over them in a moment. Please pause the video and do so. As a review, a zero of a function, as you see by the graph, is where the function crosses the x-axis. It is also known as the x-intercept, and it is also known as a root. So once again, zeros, x-intercepts, and roots are all the same. Once again, it's the value of x, which makes f of x equal to 0, as you can see by the graph. Quick note, number 1, the number of zeros will equal the degree of a function. Number 2, zeros can be real or complex. Complex is when it's written in the form of a plus bi. Remember, I is imaginary, which is the square root of -1. This will be the only time we will deal with imaginary numbers. Number 3, real zeros are found on a graph. Complex ones are not. And number 4, zeros can repeat, and this is known as multiplicity. If a zero repeats itself twice, this is known as a multiplicity of 2. If a zero repeats itself 3 times, a multiplicity of 3, and so forth. Please move on to the next slide. Together as a class, let's just work this out. We are going to fill in this table. This should help in answering all of these questions. So let's go and work on the first one. F of x equals x squared plus 1. So first question says, how many zeros are in total? Well, that should be pretty simple just by looking at the exponent. The highest degree would be 2. Next, how many distinct zeros? Well, in order to do that, we need to find the zeros. So let's go ahead and do so. So let's take this function, set equal to 0. Which of course, when we do that, we are getting plus and minus I. So how many distinct zeros are there? Distinct means different. There are 2. Let me move this up a little bit. The next question, list the distinct zeros. Well, there are none, because if we see, they are both imaginary. And again, these are my zeros right here. X equals plus and minus I. Next, list the distinct complex zeros. Well, we already saw complex are ones that include imaginary numbers, so plus and minus I. And now, how many zeros would you see on a graph? Because these zeros for this function, x squared plus 1, are both complex zeros, therefore we will not see any zeros. We will see none. 0 will appear on this graph if we were to graph this, because they are complex. Now let's go ahead, look at the next example to the right. If x equals quantity x squared plus 4 times x plus 2 quantity times quantity x plus 3 times quantity x plus 3. Well, let us find the zeros, which means we have to take the function and set it equal to 0. Which means x equals, and I will, I'll go ahead and just show the work just to be on the safe side. X plus 2 equals 0, x plus 3 equals 0, and also x plus 3 again equals 0. So that means over here I can subtract the 4 over, take the square root, and that gives me plus or minus 2i. And of course here x equals negative 2, here x equals negative 3, and here x also equals negative 3. So now, how many zeros are there in total? Well, in this case, there are 5. And we can get that by simply, well, one, you can count if you wanted to. We have 1 and 2, 3, 4, and 5. Or you can simply look at the original problem. There's a degree 2, degree 1, degree 1, degree 1. We simply add them up, and we get 5. Next question is how many distinct zeros? Distinct means different. In this, there are 4. We have 1, 2, 3, and because this is the same, that would be 4. We will not count that twice. The next question lists the distinct real zeros. Well, in this problem, they are negative 2. Distinct means different, so I will not repeat, and negative 3. Next, list the distinct complex zeros. Well, we have plus and minus 2i. That is complex. And lastly, how many zeros would you see on this graph? We would see 2. We will see a 0 on the graph, which is also a root, at negative 2, and we will also see one at negative 3. And again, negative 3 is the same point, so it only counts as one root on a graph. So we will see 2. So I hope this helps in learning and figuring out how to tell how many zeros there are in total, how many distinct zeros there are, if we are trying to find the distinct real zeros, if we are trying to find the distinct complex zeros, and also how many zeros you would see on a graph. Please move to the next slide. Please take a moment, copy down the directions, and then for numbers 1 and 2, find the real zeros of f of x. Please pause the video and do so. In order to find the zeros of a function, I must set that function equal to 0, so let's do that. So therefore, I'll take 2x squared for number 1 minus 13x plus 11 equals 0. This is a quadratic equation. So let's see if we can factor this into 2 binomials. Because I have 2x squared in the beginning, then that tells me this must be a 2x and an x. Because my signs in the quadratic are minus plus in that order, that tells me signs must be minus. And if I now look at the last times last, which is the 11, that tells me 11 and 1. I just need to figure out where it goes. I will guess there. Let me quickly just check to make certain it's accurate. When I FOIL, that gives me 2x squared, check. That gives me minus 2x, the outside. The inside gives me minus 11x, minus 2x, minus 11x combined gives me minus 13x, so that checks out. And then when I do last times last, that gives me positive 11, and that checks out. Good, so everything works. Now all we need to do is to set each binomial equal to 0 and solve. So both of these values are real numbers. So therefore, I will have zeros of 1 and 11 over 2. Now let's look at number 2. Once again, to find the zeros, let's set it equal to 0, the function itself. Good. Please do not divide by an x. Oh, I forgot the x here. So now let's first factor out an x, which gives me x squared plus 36. And that equals 0. So let's set each of these equal to 0, since it's product. So that first one is easy. x squared plus 36 equals 0. Of course, x squared equals negative 36, and x equals plus or minus 6i. Now, once again, what are the real zeros? Well, in this case, the answer is only 0. That is because we have complex zeros here, and the question did not ask us for the complex, only the real. So therefore, the answer to number 2 is only 0. Please move on to the next slide. Take a moment and copy down the note. We will then work out the example together. If you think you can work out the example on your own, please do so. Please pause the video. Note, if r, some value r, is a real zero of the function y equals f of x, then we know two things. One, x minus r is a factor of f of x, and we should know that because anytime you so far have had a quadratic equation, you would then, if possible, factor into two binomials, which of course this could be one of those binomials. And then you would always set each binomial equal to 0. And then when you solve, at least in this case, number 1, you would add the letter r or whatever number to both sides. And in this case, x equals r, which is why that is. So this is something you should already know. Maybe you haven't thought of it this way, but you already know it. And number 2, if r is a real 0, then that means r is a solution to the function. Meaning, if you take that real 0, substitute it into the function, simplify it, you will get 0 out. Example. Find a polynomial function with the given zeros. Well, for number 1, first of all, in order for it to be a function, it must be written as f of x equals, or you could use g of x or k of x or anything similar, or even y equals. So f of x equals, if 1 is a 0, then according to up above, number 1, then that means x minus 1 is a factor. And if negative 2 is a 0, then that means x plus 2 is a factor. And that's it. If you want to multiply and FOIL that out, you can. It is not needed. As it sits, it is already in factored form, and this is probably the best way to write it. Number 2, using this same idea. First of all, it needs to be a function, so I'll start with f of x equals. If 2 is a 0, then x minus 2 is a factor. If square root of 3 is a 0, then x minus square root of 3 is a factor. And if negative square root of 3 is a 0, then x plus square root of 3 is a factor. Now, this is a fine answer. However, most directions will ask you to write your function using integer coefficients, which means this and this here. These are not integers, which means you would need to multiply at least these two out to get rid of it, which means we would get an answer of x minus 2. And now if you were to FOIL out these two, you will get x squared minus 3. Now for this I will put or. Either one of these two will be fine, but please know most directions will only tell you to write it this way, which would mean the one up above would be incorrect. So something to keep in mind. Please pay attention to the directions if they are wanting your answer using integer coefficients. And lastly, number 3. And this is a good one because now it talks about multiplicity. So f of x equals, well, if 0 is the 0, then that means we have x. If negative 1 is the 0, then the factor is x plus 1. If 4 is the 0, then that means x minus 4 is the 0, but it says it's a multiplicity of 2, which means there are 2 of them. So you could write it as such, but that doesn't make sense to leave it as x minus 4, x minus 4. So instead, let's write it as x minus 4 quantity squared, which I think is also better because if there's a multiplicity of 2, you can immediately see that by the exponent. So this is the best way to write number 3. And now you can see how we will write polynomial functions with given zeros when there's a multiplicity. Please move on to the next slide. Please begin the homework.